P2 over R is 2. So therefore wrong. Yeah, R over Q is infinity. So that is correct. N plus 1 reset means Li must be there. Right, T of 1, 1, 1. So T of 1, 1, 1 can be written as 0, 0 plus 0, 1, 1. Why? Because linear transformation. Therefore, image is just 1, 0 plus 1. And that's going to be 2, 1. Moving on. Yeah, same reasoning. What will be this? Okay. We know that x to the power n minus x minus 1 is equal to 1 plus x square plus and so on. And due to this factor, this is just x to the power n minus 1 and I, so C. Yeah. Okay. Mistake. So this is wrong, this is correct because it's not 54 multiplied by 2 to the power 3 cross 3 matrix. So maybe not that. Maybe 4 probably. Okay. A system of equations. We reduce it to the row form. Therefore, we're getting rank of A is equal to rank of augmented of A is equal to 3. And if rank of A is equal to rank of augmented AB is equal to number of unknowns, unknown to be specific unknown variables, then there exists unique solution. There are 1, 2, 3 unknown variables, so therefore is consistent. Yes, since augmented was and unique solution indeed exists. Right, the eigenvalues. Okay. Lower triangular matrix eigenvalues are 1, 2, 4. Then what is A? This is your A. A square will be 1, 4, 16. And minus 3A will be minus 3 minus 6 minus 12. That's going to be 2i. So eigenvalues of identity is just 1, 1, 1 multiplication by 2. So 2, 2, 2. You add them up. Add this boy up. Add this boy up 0. Add this one. So only one equation was satisfying that. If is a matrix, is that non-real? Of course, never triangulable. Two distinct eigenvalues. At least two eigenvalues. Well, not necessary. If we critic with 3 cross 3, it fails. And not a necessary condition. Therefore, transpose is correct. Synchronous with all entries equal to 1. So characteristic x raised to n minus 1 lambda. If we do lambda characteristic eigenvalue, and the other will be just be the order of the matrix that guy. So n, so eigenvalues are 0, 0, 0 for n minus 1 values and 1, 1. So has exactly 1, 0, other fails. Easy condition, adjoint of A is equal to B. You know that adjoint of A is just 1 by determinant of A into A inverse. So it is only invertible when the other is. So it is a biconditional if and only. Yes. 2 is positive. 2 cross 2 if we check all the such ones. 4 minus 1, 3. Check all of them. Yeah, it is, yeah, like 1. Here also 1 minus 0. This one is also 2 minus 1, 1. So all are positive, and then 3 order determinant is 3 into 2 minus 1 minus 1. 1 into 1, so that's going to be just 2 minus 1, which is 1, so therefore positive definite. Right, moving on to the real boy. Right, let X be a connected metric space, then which of the following is true? X is finite. No, not really. Take R. Infinite. I'll take the singletons. Fails. Uncountable. Of course, this is not uncountable, so this is false. X is not equal to 10, so that makes sense. All right. Yeah, you can directly say by theorem. Dense, no need to do anything there. So the following statements is not true for any metric space. Every open set is closed. Not really if you take the interval 0, 1. So that's not the case. Every subset is bounded, but this is not true in any metric space. It's only for finite cases. If you take naturals or rationals, then it fucks up. Apart from that, there is a countable set which is not countable, obviously n. Or there is a finite set which is not closed. That will be true. Okay, yeah, this is wrong. Actually, this is nothing but 1 by n plus 1 by n square. N square is pi square by 6, but this is divergent, therefore divergent. Okay. This one was supposed to be false because the sequence is constant sequence 1, so therefore this is true. Screwed up there. Full screw up. Right, f is sequence defined like this, then which of the following statement is true? Sequence is uniformly convergent. No, not really. Because if it is limit, but it's pointwise, it is discontinuous at x is equal to 1, so not possible. Suprema identically 0 because at 1 by 2, any number in between will be 0 because 1 by p to the power n this type of form. So it will tend to 0, so it is identically 0, that is correct. And since it is identically there and limit is 0, therefore you can even apply Weierstrass test. The only largest value we can get is at 1. Before that it is just 1 by pn form, and at 0 it is 0, so therefore just 0. So S2 and S3 are correct. Alright, suppose that f is defined by, alright, derivatives already computed. 2x minus 1 minus 2x 3x square. This is the case. So you put the value directly, f dash of 1 will be 3 over 3 minus 2 whole square. Doesn't really matter, that is 1. So this is 9 f dash square, so that's going to be just this. So inside is going to be this 3 square now. Just take the square root. So that's going to be 3. So this is going to be 3. And f double dash is this. Put x is equal to 1. This is 1 over 3 minus 2 cube, which is 12. 15 minus 1, so that is 6. Alright, for continuity, take y is equal to mx. So then mx square, yeah, mx square over x square plus mx square. So that will be m upon 1 plus m square depending on m, so therefore not continuous. Partial derivative, okay. We'll just take symmetry case, because at the upper it is that. So that is f of x h is 0 minus f of 0 0 over h. Since due to this 0, this is entirely 0. Denominator is just 0 upon h square divided by h square, but this is 0, so this is going to 0. Therefore partial derivatives exist and are equal to 1, and just like this. What value should it be continuous? First of all, here it is 0 upon 0 form, so by L'Hospital minus sine pi x upon minus 1, so sine is equal to 1 by x. Now it is continuous at pi by 2, therefore lambda is equal to 1. Right. Screw up. Non-empty subsets and proper. Non-empty means exclusion of empty set. Proper means exclusion of x itself. So therefore 2 to the power 5 elements, 2 to the power 5 minus 2. That will be 32 minus 2. That's going to be 30. Damn it. Alright. Suppose new section. Yeah. Right. Clearly due to this there will be two disjoint stuff, so due to that union of open sets, so that's going to be open. Union of open sets is open, that's open. Just basic. I think here it is like open question, because it's not the case. Like open question, all could be wrong as well. That's why just a guess over fucking B option. Check the following statement is false with respect to discrete topology. I think B. I selected this, not much intuition over topology. Alright, coming to this one. So it's C with the closed subset of R. C with the interval. C, if it is, see, if an open interval is intersecting with a closed subset, and closed subsets could be natural number, integers, or closed interval. If it is at, if let's say closed interval is this, but it is saying for any means it can be any of R, so it should always be non-empty. So therefore you cannot take closed intervals, you cannot take natural numbers, because if you take natural number it is a discrete set. If you just take this, then it is empty. So like that. Same for integers in other set. So that's why we must forcefully take C is equal to R, which is not countable, not bounded, not compact. Come on. Not connected means you're excluding these 2 points. So that automatically becomes disconnected. If you remove 1 point, that's not going to cause you any trouble. If you do this is just straight up stuff, no problem. And again, this is not a problem. Okay, this is a bit problematic because they're saying normal space, but a normal definition is a bit fucked up here. Actually, it should be U intersection V should be empty, but there must exist an open set that is so like normal space means this is a closed set U, this closed set V, so there must exist a set open set G which will separate them. It's like that. No proper definition was given here. So ambiguity. All right. Now from here, I think Park Brother. Right. Right. If you tend this towards very smaller points, we'll get lots of points there. So clearly it is not compact because it is compact would imply compactness in R2 means closed and bounded, but not clearly bounded, so therefore fails. As for connected, you can see discreteness is there, so no connection, so not connected. Need to be intervals and those stuffs minimum. Okay. Again, this one was like a guessing, you can say. Yeah, once again, this one is just took it like a expression. Yeah, so this one, so such cardinality cannot be empty because that would support it to be decreasing size, so that is not possible. So therefore option A is false. Cardinality cannot be simply be 1 because there are more cases. Cardinality is not again strictly infinity. Infinity is not even a cardinality. There are a C and a F naught. Continuum and a F naught are there. So not possible. Okay. Moving on to ordinary differential equations. Okay. It's ODE and PDE. Okay. Yeah, again, this was basically, I think, so D, just eliminating the parameters. All right. So two solutions are there. Already, this means this is Wronskian at x is equal to 0. So Wronskian of 0 is given. They're asking Wronskian at x1. So by this formula, w of x is equal to. So actually, it should be like this. Of course, integration of e to the power. What is the p term here? -2 and also x because it is a differentiation of y. So dependent variable is y, and the integration of 2x dx is just e to the power x square, so it will be just x square, but it is at 1, so at 1 it will be e to the power minus 1. Wronskian of this is just a determinant, so that is into this, so 2 minus 2 minus 1, that's going to be 1. So 1 into 1 by e, the answer. Right, simple. Take the partial derivative of this is your f. Partial derivative of f will give you x into cos y plus cos x. If you take the modulus of this value, it will be just mod of x more cos of y plus cos of x less than or equal to 5 1 1 to 6. Basically, if you let's say you have a solution for this is going to be yc1 m1x m2x. If the real parts of the characteristic roots are negative, then what will happen is, if this is negative, so exponential minus x will tend to 0, so therefore this is correct. As x tends to infinity, this will tend to 0. But if the roots are positive, so e exponential x tends to infinity as x tends to infinity, so therefore this is false. Right, this was just a coercive setting, something like that. Fine, extremely easy. Already we have done this, so just y is equal to integrating factor will be x square, so exponential minus x square integration of 2x integrating factor is exponential x square, so exponential x square will get cancelled. Let's see, so that's going to be just x 2x, so 2x plus c exponential x. So option A for this one. Just by analyzing you can get that. Intersect orthogonally probably, because this looks like a Pfaffian and this is Lagrange auxiliary equation. Okay, this is we can see Lagrange auxiliary equation, that's dx upon y is equal to dy upon minus x. Z integrated will get x square plus y square is equal to c1 square and z is equal to c2, so you can just replace them and get unique solution somewhere. Probably finitely many are infinite as well. Yeah, 40 it's not that. We'll get a unique curve through the, so probably I think unique general and unique complete, because they are unique. When you substitute you'll get particular. Characteristic curve of a one parameter family is a locus of all the common points. Yeah. Envelope is obtained by eliminating parameters and solving it for them. So both. No, not every Pfaffian is integrable. Only it is only integrable when x dot curl x is equal to 0. And this is just a determinant, so this is just the determinant over the partial derivative. Like curl will mean that I, j, k, and then derivatives with respect to x, y, and z, and then the variables p, q, r. You can see for this one it is just like that. All right. Hyperbolic. Okay, this is your a is equal to y, b is equal to 2x, c is equal to x, b square minus 4ac. implies 4x square y square is equal to minus 4 x into y. That should be for hyperbolic, it should be greater than 0. 4xy x minus y less than. Now if x minus y is less than negative, so this is negative, this is inside quantity is negative, negative times negative is give you a positive. So therefore that is the answer. One parameter family through 0 0 to the integral surface. Just guess. No fucking idea type question. Again, this was a on the time guess. No fucking idea. Right, the first one is correct because forward operator of fx, which will mean it is just f of x plus h minus f of x, which is f of x plus h minus f of x. This is minus f of x plus f of x minus h. Now if you see the RHS over f, that is going to be f of x plus h minus f of x yes, f of x minus f of x minus h, so therefore it is true. Yeah, this is equal to n factorial, so constant. Think this is a linear operator, so therefore it will satisfy linearity. Therefore I'm getting option A. Oh, this was numerical miscalculation. Okay, trapezoidal rule. No fucking idea. Any percent, idiot. Yeah, after the entire fucking circus, it is this. It's nothing. I'll just define this one. F of x plus h minus f of x. This is f of x plus 2h. It's f of x plus h. This is going to be f of x plus h minus f of x minus into minus plus. So this is just of x plus 2h minus 2 times f of x plus h of x. Computations give you same straight. Simpson's 1/3 rule. No fucking idea. No fucking time to solve those questions. Right. Extremal of the functional. I'll just go with this one. No fucking idea question. Shortest distance in a 3-dimensional Euclidean space. We'll just take a space sphere and any 2 points. You see it is cutting. It's not a plane probably. A surface by a plane. I think it will be like a circular region, therefore by the plane to the center of the sphere. Okay, time taken by a particle moving along a curve. So curve. Ah yes, brachistochrone problem. Thousands of videos on YouTube. That's how calculus of variation started, by the way. Okay, directly, since in the fx yy this is absent, therefore this one I suppose. Right, fy minus fy double prime y prime, and prime is equal to 0. So 2y minus 2y prime is equal to 0. So y plus double prime. Auxiliary equation will give me m square plus 1 is equal to 0. So y is equal to c1 plus cos x plus c2 sin x. When you put the 0 is equal to 0, this is 0. So implies c1 is equal to 0. Therefore reduction is over c2 sin x. So c2 you can substitute b. That is the answer. So no fucking idea, I just went with. For the homogeneous integral equation, I'll just seems too fucking obvious to be true. You can apply Laplace transform and get probably root t. No idea. No fucking idea. Right, and the boundary value problem is equivalent to which Fredholm integral equation? Okay, y of 0 is 0 and y prime of 1 is equal to 0. Okay, just integrate it, so that's going to be y prime x minus initial condition is 0, so no need to write that. Lambda integration. Okay, just fucking ignore it for now. C1 you reintegrate, and since the initial condition is 0, so therefore it's going to be y of x plus double integral. So again x cubed by 6 plus c1x plus c2, and so equation will be of the form yx is equal to, if you shift it there, minus lambda. Okay, convert it into singular integral, it will be x minus t, because integration was with respect to t, so t is there, so limit is x, and therefore only one of the options contain that. Option C, rest do not contain. Rest contain weird ass kernels which are not fucking possible. Not possible kernels. KXT is just too arbitrary. Okay, no idea. I did not have time. We had to calculate the Fredholm determinant, but I'll just go with minus pan pi. Alright, since this is nothing but a to the power t into minus s, so resolvent is as it is. Just say this one. This is actually equal to minus 1 by 2 1 to t, and as soon as upper limit is t, it becomes Volterra. Okay boy, what the fuck is this? Combined was 34. Okay, now this is why the fuck they have classical mechanics as mathematics. No fucking idea for any of the questions. Entire skipping, but I think this one is solvable because this one is this. Nice solution there, probably. All right. Yeah. So e to the power minus I into z will be greater than 1 when minus I x plus IY. So that's going to be minus IX minus into minus plus exponential y should be greater than 1. This is modulus imaginary is 1, so no problem. So exponential y, which is imaginary part. Periodic projection simple formula is there. Actually this is true, not exactly false. Basic theorem. Again, this has a 0 of order 1, so 1 pole is of order 1, so 1 1 minus 1 0, so therefore removable singularity. And gamma be the unit disk with an analyticity. Okay, this means Schwarz lemma. Actually this is false. This should be correct or this should be correct. One of them is there. This could be more true because f of dash is actually holding to be there. Equality holds, na? Equality holds when it is a rotation mapping. That's why CZ should have been given, but okay. Screw up at this question. I'll write this one. Okay, circle is at the center, pi by 2, radius 1. Radius 1 means it will also contain 0 as well. Idiot. Like this it will be. Okay. Therefore, poles are z is equal to 0, z is equal to pi by 2. So residue will be 2 pi I times residue at z is equal to 0. At z is equal to 0, we'll ignore this one and take this, so z of sine of 0 0, so 0. When we are checking residue at pi by 2, we'll ignore this one and see over this 2, so this is 1 over pi by 2. So that's going to be 2 by pi. Pi cancel, 4i is the answer. So the following maps unit disk onto the right half plane. Basically, if it is right half plane, that means for any points it will satisfy. So take z is equal to 0. So this is minus 1, not possible. Minus 1, not possible. Minus 1, not possible. And this is going to be plus 1. This is possible, so therefore it is actually being mapped to right half plane. Yes. So if you put z is equal at 1 means does not have a radius of convergence 1, so this should not be equal to 1. So let us see at that point. If you put z is equal to 1 here, so this is just 1 by 2 and so on. This is just a geometric series with common ratio 1 by 2. So 1 minus 1 by 2 to the power n upon 1 minus 1 by 2. Since this is going to 0, so this is going to be half, so this is going to be 2. 2 is not equal to 1, therefore this is correct. Yeah, no fucking idea over this. Conformal will mean that derivative of fz is not equal to 0, therefore this is wrong, this is wrong, this is wrong, this is correct. Consider which of the following. It's actually not. Both are false. And this is because sine z. This again, no fucking idea. This is creating essential singularity, therefore dense in C. Okay, straight up just take I can be written as e to the power cos theta plus I sin theta e to the power pi by 2. You can get your answer later on. As for this, just take squares and modulus will get. It's a minimal polynomial of this. Fuck. No goddamn idea over this. Stupid as MSC. Yes, so this one there is no subfield with k elements to the field. So I think k must divide 2 to the power 6 or 6. 2 to the power k must this k must divide 6. So 1 can divide 6, 3 can divide 6, or 2 can divide 6, but this is 4 does not divide 6, so therefore just a hypothesis. If k is a finite will need not be true. Oh shit, this is actually true. Yeah, actually I fucked up it as true. It is actually true. Saying not true. Fuck. Take z is equal to 11. It, no computation was done here. I just said both are true. Any finite non-commutative ring must have 16 elements. One is no, not necessarily, probably. This is of order p square, which is 3 square. So yeah, such a ring can be commutative. Right, SL2 over Z2. So over Z2 is p to the power 2 to the power 2 minus 1. Yeah, same as this. 3 into 2, which is 6. 6 means order of S3. It's isomorphic to S3. In fact, I think GL2 over a field of 1, 2 is isomorphic to S3. I had no fucking idea over this. This if H is subgroup of G, so that index is that. So then it is normal, yeah. G by H index is 2. Like this type of notation also works. Good example would be A N are always normal of this. N is simple for n greater than or equal to 5. This is wrong. Conjugacy does not hold there. No subgroup because it will divisors will be 1, 6, 2, 3. 2 order does not belong to A4. So only 3, 3 and 6 will generate No, but 6 is not there in A4. So only 1 and 3. So 1 and 3 LCM is at most 3. Not possible. Therefore, by elimination. You take Z4 and Z2 cross Z2. Z4 identity and 0, 2. So it has actually 3 subgroups, but if you take larger set, then it is not true. 3 square is 9, 9. Z9 has far more elements, so maybe that is the case. Right. So that is actually not correct, probably because more cases can be there. But too exactly trivial was the marked in OMR. Okay, 17 can be written as 8 plus 8 plus 3? Not really. Oh yeah, actually 8 plus 3 plus 3 plus 3. 18 can be written as 18 has no factor. So that's why probably 15 maybe. Either there are units or zero divisor. For units we have 5 of 12. 12 can be written as 4 into 3, which is 2 square, into 2 into 2, which is going to be 4. Okay, this permutation is just 1, 2, 3, and this is equal to this. This is of order is only 1. Order is 2. 4 order is 4. But this one is 2, 2, sorry, this is 2. And this order is 3. This order is 3. So therefore, option A is correct. We selected option A. It's a bit basically it will mean eventually constant, which could imply compact because the norm is supremum. Okay, actually this is compact. This is compact in R. This they are closed and bounded. Therefore, these are never possible. This is also compact. Therefore, this is also false. Actually, this is correct. Yeah, I marked option A only. Like this. This is the end. It was nice. We'll do net or gate again.